Pixel
Right.
coin.
Hey guys, thank you very much for BNY to actually give us a space here and for Yiseul to organizing the event. So I'm here from a company called Tendermint, and tonight I will give you a brief glimpse into technology that we're actually building, some of the products that we're bringing out to market, and the team behind it, and so on. Wait, there we go. Is this actually working? Yeah. So let's get started. I'm Adrian. I'm one of the core developers at Tendermint. My background lies in software engineering and development, and business management. I've two random facts about me. So I've lived and worked in Denmark, Canada, the UK, and Germany, and I'm an avid drone enthusiast. So I fly small racing drones on the weekend. Within the blockchain space, I'm mostly focused on consensus engines, e-voting, gambling, and usability. You might realize that only one of them is actually in the protocol level, and the rest is on the application level. It's mostly because I very much believe that blockchains will change the way we, change the way everyone transacts, but that won't happen on the protocol level. So for this, we need to make it usable at the application level, so that even my parents or my grandparents are able to use it, right? Very much like Facebook. Now, let's get started with a couple of questions so I get a feeling for the audience. So who here has heard about Tendermint, Ethermint, or Basecoin? Sweet. That's actually more than I expected. That's maybe 25, 30 people. Cool. Who has installed any of the previously mentioned programs? Still 10. Nice. All right. Who has tried any of our testnets? So currently we have 3 testnets live. One guy. 2. Nice. So just for your information, we have 3 testnets live. One for Ethermint, which runs our Ethereum fork, and 2 for Basecoin, where I will talk about it in a bit as well. And then the final question: has anyone managed to send coins between the 2 Basecoin testnets? Okay. Really, one person. Sweet, nice. Congrats. Because this is what Ethermint, or what Tendermint is really about, building the Cosmos Hub, which allows blockchain interoperability. So you can have 2 completely separate blockchains, but you can send money through another blockchain, which we call the Cosmos Hub, to the other blockchain, which means that suddenly most of your scalability issues go away. Traditionally, when you look at Bitcoin or Ethereum, you start running into the problems when you can only have 7, or in the case of Ethereum, maybe 15 transactions a second. But anything beyond that, you kind of either have to move off-chain or worry about the network being clogged up due to one of our famous ICOs, which isn't great if you actually want to use it in a production environment, and suddenly the entire network goes down for 2 days because a random company raised $200 million. And I will talk a lot about this, that you can move coins between 2 separate blockchains, because suddenly you have the scalability opportunity where if you need more transaction volume, transaction throughput, instead of having to build a better blockchain, a larger blockchain, you just spin up another network which you connect to the hub, and suddenly you have double the capacity. All right, cool. So a bit about the team that's actually developing Tendermint. Currently we're roughly 10 people, growing all the time though. So we're a core team of 10 people. 8 out of 10 people are developers. We're also always looking for new people, so we hired a bunch of DevOps people lately, because we needed testnets, so we needed DevOps people. So if you're interested in anything I say, or interested in blockchain space, or experience in Golang, come talk to me after. We're looking for awesome people. So what do I actually do at Tendermint? I mostly work on 2 projects, which are Tendermint Core, which is our core consensus engine, which implements a proof-of-stake algorithm and a peer-to-peer networking layer. And then on top of this, you can write arbitrary application logic. And I work on Ethermint, which allows you to run standard Go Ethereum, but on top of Tendermint consensus. So instead of 15 transactions a second, you get about 200 transactions a second. And the cool thing there is that all the normal tooling still completely applies. So everything that the community builds around Go Ethereum, or Ethereum in general, still works with this because it's fully RPC compliant. Also, I'm working on peg zones. So on how do we take, for example, a Bitcoin and transfer this value to the Cosmos Hub, and then how do we transfer this Bitcoin Cosmos Hub back to the Bitcoin network? And how do we do this securely? Quite an interesting challenge. Also, I don't know if any of you know the Rust programming language. I'm a huge fan, so I'm building also Rust language support for Tendermint, and a bit on enterprise integrations and developer outreach. Yeah, so but what is actually the Cosmos Hub, right? That's a kind of question. And for us, it's the solution to scaling blockchains. Instead of having this single monolithic kind of blockchain architecture, you have a hub, or theoretically in the future, this will also scale that you don't have one central hub, that you have multiple disconnected hubs. But in the beginning, it's one central hub. And then every blockchain that you want to run, you can connect a blockchain to a Cosmos Hub. And now you have the chance to send value or tokens between those two different blockchains. Let's take the example of Ethereum. So I have money in Ethereum, I have Ether. And I would like to interact now with Ethermint. And for Ethermint, I need money as well to run a transaction. So I can take an Ether and send it to a third zone here, which is the PEG zone towards Ethereum. You can send the money to the PEG zone, and how this bridge works, we're currently working on this. It's totally feasible thanks to the script, thanks to Solidity though. From the PEG zone, you move towards the Cosmos Hub, and from the Cosmos Hub, you can then move into Ethermint, run your transaction, and then send your remaining Ether from the Ethermint zone to the Cosmos Hub, back out to Ethereum. Now imagine this, you also have it for Bitcoin, you have a bunch of other blockchains which we haven't thought about yet. Oh yeah, the late comment, so sorry.
What's your name?
So this is what the Cosmos Hub is about. It's about scalability for blockchains. And something where you see here, arbitrary business logic. So what Tendermint itself only provides is consensus and peer-to-peer. Which means that, for example, if you want, currently we're building an invoice tracking app. Because as a company we have expenses and we need to keep track of who bought what, and we need to pay these people back. We're building a blockchain solution for this. This also plugs into the Cosmos Hub. So you track the expenses and then you move the value from those expenses across the Cosmos Hub and can use them on other chains. Right. Yeah. So just an overview again, what we're building Tendermint Core Engine, Basecoin, which I actually haven't talked about. Basecoin is our multi-asset cryptocurrency. It will form the backbone for the Cosmos Hub. It essentially allows you to track an arbitrary amount of different cryptocurrency tokens under one account. Yeah, and this will be used for the Cosmos Hub to actually track the movement of tokens across the Cosmos Hub. Ethermint, I talked about the ABCI interface. This is especially interesting for the developers in the room that want to build their own blockchain solutions on top of Tendermint and Cosmos. With this, you have to fulfill, I think, a 10-method interface, and then you have an up-and-running blockchain where you don't have to worry about the peer-to-peer layer or the consensus layer. And the last cool thing actually also is a decentralized exchange. So now that we have all these tokens moving in the ecosystem, how do you swap one token for another without having to trust your tokens to a central party? All right. Let's actually go a bit more into detail on not detail. When I'm saying detail, I mean like very brief detail. We could talk for like 2 hours about this. But how does Tendermint actually work? So if you're a client, if you build your client application, or you're building a client application, you submit, this is your client application. So you're only building the green box, the application logic. Now you're running a Tendermint core instance. And a user submits a transaction, which is literally just a stream of bytes towards a Tendermint instance, which is now stored in something called the mempool. From here, Tendermint goes and says, right, let's see if the transaction is valid, let's check the transaction, is it well-formed, is it malformed? And the application just says yes or no. If it's a well-formed transaction, Tendermint starts gossiping it to all the other connected nodes. And all the other nodes do exactly the same check. Once it now comes time to actually create a block, which happens with Tendermint by default about once every second, the lower part kicks in, where the consensus logic then asks, now give me all the transactions you have. Let's say you get 100 transactions back, and then Tendermint Core goes to your app. So by the way, the yellow part, you don't have to worry about at all. This is all done for you. You only worry about the green part. Now it goes these are my 100 transactions. I've established the total global ordering of these 100 transactions. Application, update your state, right? Because a blockchain in the end is only a database. It's a database over which you run some transactions until you arrive at a new state of the database. And then, in the end, what happens is the application only has to give back one value, one hash sum of the state at that moment. And this value is then included in the Tendermint blockchain. And the most awesome thing is, if you, first of all, for you as a developer, it's much easier to build it this way. Secondly, if you actually build it on top of Tendermint, you can easily plug it into the Cosmos Hub. Plugging it into the Cosmos Hub only involves implementing something called the IBC protocol, Inter-Blockchain Communication Protocol. It's like 5 messages that just define how you send messages between different blockchains on the Cosmos Hub. Yeah, so why Tendermint? So what's the benefit of using Tendermint, and what makes us different? Tendermint is one of the few companies implementing a proof-of-stake consensus algorithm. So we suddenly have all the advantages of not wasting electricity, which in the case of Bitcoin is something like the electricity that Island uses right now, to secure the network. And instead of using the electricity consumption as a security guarantee, we use security deposits. So when you are in the Cosmos Hub, there are validators. And these validators have the right to create new blocks. However, if they abuse this right and try to cheat the system, they lose the security deposit. So the security deposit gets slashed, which is why there's huge economic incentive for a validator not to misbehave. Furthermore, so we're in the process of getting it formally verified right now, that the consensus algorithm actually works. And as far as we know, we're one of the only companies that is actually safe against the long-range attacks, where validators have nothing at stake, so they can start cheating light clients once they come online. And yeah, also, we're one of the few companies that have a full specification of a proof-of-stake consensus algorithm actually published on GitHub. And by the way, we're not inventing like everything from scratch here. These consensus algorithms go back to the 1970s. They're very well researched in computer science. Yeah, we give you some guarantees, and the only thing we have when we have a weak synchrony assumption, that essentially means we're dealing with timeouts. And yeah, we're optimally visiting fault tolerant. So in order to violate the safety or liveness of the network, you actually need to control more than 1/3 of the nodes. So some of you might argue, but what about Bitcoin? Bitcoin is safe against until you control more than 51% of the network. Technically, theoretically, that's might be true, but technically speaking, as long as you control some parts of the underlying networking stack, Bitcoin is also susceptible to roughly a 1/3 attack, because you can split off entire parts of the network, so you drop off entire parts of the hashing power that secures the network. And probably the coolest thing about the Tendermint consensus is actually that it's fully fork accountable. So in normal operation, there should never be 2 conflicting blocks at the same height. However, if there is, because one of the nodes actually cheated, we can exactly pinpoint who cheated and when. And so accordingly, we can punish them afterwards. This also plays into the slashing of security deposits. Oh yeah, and probably if you've developed software before, one of the biggest things is the entire implementation is like 25,000 lines of Go code, which means it's very short, very concise, it's easy to verify. If you as a company want to run this, it's literally you need to hire 2 engineers to look at the code and see whether it actually does what it says it does. Oh yeah, so maybe some properties now. So Tendermint itself in its raw form supports roughly 10,000 transactions a second. But again, this isn't a limiting factor, right? With 10,000 transactions a second, we are already much faster than Ethereum or Bitcoin. And again, this actually does scale even further, because as soon as you need more transactions, you spin up a second Tendermint network, and you hook them up through the central hub. And now you might wonder, so how come that Ethermint, our Go Ethereum implementation, only supports roughly 200 transactions a second. That is mainly due to the actual application. So on the application side, speed is also important. The faster you can make your application, the more transactions you can get a second. Another property of Tendermint is that you have fast and permanent block finality. So traditionally when you work with Bitcoin or Ethereum, you normally wait between 6 and 12 transactions blocks until you're actually certain that your transaction was included. With Tendermint, after 1 second, you know your transaction is included, because as soon as it's in a block, it's completely permanent and cannot be reverted.
So you mentioned the scenario earlier,
yeah,
in which a bad actor would be penalized.
Actually, wait,
So
can you hold on to your question until we have like 5 minutes Q&A afterwards?
Sure.
So fast and permanent block finality. Also, since it's proof of stake chain, we're able to build very efficient light clients. When you talk about Ethereum, suddenly you have to come online. You have to actually keep up with all the headers to keep up as a light client to make sure that if you could receive a block from the network, that it's actually a valid block and no one is tricking you into seeing a state of the world that is actually fake. With Tendermint, as long as you have those 100 initial validators, you only have to come online to track the changes in the validator set. And if you're running a light client on your phone, you can take any random block and verify that it's actually correct and that is the actual state of the world at that state. For example, an idea I was thinking about yesterday: efficient mobile banking clients. Right now, a banking mobile client is very susceptible to like man-in-the-middle attacks and so on. With Tendermint, you could essentially build a mobile client that doesn't have to trust the origin of the data. So it can connect to any node worldwide, and it doesn't matter whether the node lies to it, because the light client can detect whether it's being lied to. Also, maybe if you run this in a federated sense, so if you run it between companies, the cool thing is the validator set is known and accountable for. So if someone tries to cheat, you can exactly pinpoint who cheated and when, and then punish them accordingly. Of course, in the public network, we use security deposits, but in a private setting, you might want to just know who did it and then punish them through other means. And lastly, regional zones. So the ability with the Cosmos Hub to have multiple zones interconnected, multiple blockchains interconnected, can lead to a setup where, for example, London, all the financial payments within London are handled on one zone. And then if I take out my card, this goes to the London zone, the London hub. And then if I go to Manchester, I can still pay, but I just pay on the Manchester hub, and this interconnection is just done once to connect the London zone to the Manchester zone. With this, you get extreme fault tolerance, because suddenly if half the network, for example with Bitcoin, if China drops off the internet tomorrow, Bitcoin's block time will probably shoot up by like 3 to 4 times, because like 40% of the hashing power drops off. This doesn't matter, because even if everything else but London goes offline, we can still transact in London. And then once the rest of the world comes back online, we just sync up with the rest of the world. But we don't have to merge 2 chains, because there were never 2 chains in the first place. How am I doing? 8 minutes, perfect. So how do you write your own application? So currently I would say that most banks, from my experience, are experimenting a lot with Go Ethereum and Solidity. And so you can do this with Ethermint. You just get faster block times and easier setup. And you get all the security guarantees of proof of stake. And that's probably the easiest way, because you can use all the existing tooling around that you already have for Go Ethereum. If you're more experimental, so interesting fact, in Denmark, where I currently live, the banks just updated to the latest technologies in terms of programming languages, which in their case is Java 6. So if you want to build on top of Java 6, you can. You can write it in any language that you want, and currently we support Rust, Java, Go, JavaScript, or if you have really need for your own language, we can probably talk about that as well. And the only thing you really have to do is you have to implement a couple of required messages to fulfill the ABCI server protocol. So that your app is essentially a server, and every once in a while the Tendermint core instance goes, I have a new transaction for you. Please, is it okay? I want to mine a new block. Here are a bunch of transactions. Please run them, and then return me a statement. That's all you have to do. Yeah, and again, I talked about this earlier. This is essentially how it looks. It's very easy. I have a lot of extra resources where you can find more information about this. Thank you very much. If you have questions, please don't hesitate to contact me. I'm always happy to help people start getting going with Tendermint. Thank you very much for listening. And the Q&A.
Yeah, sorry for interrupting.
That's okay.
Yeah, so it's just a query around the topic of finality. Because as you highlighted, the other permissionless blockchains that require proof of work would exploit the idea of multiple iterations, and they have 6 or whatever transaction cycles, to increase the likelihood of there being legal finality.
Yeah.
It's unclear when that would occur. As you state, you achieve finality in one game. I'm trying to reconcile that with the idea that you may have bad actors who would then get penalized in subsequent iterations. Ethereum and so on could solve that by, in subsequent iterations, other people addressing it. So I'm trying to work out how you would solve it. Is it really finality? Would you undo it? Are they reversible?
So it's not revertible. If your transaction is in the block, it's completely final. But a bad actor could try to cheat the system by submitting. So transactions are ordered before a block is created. So all the network agrees on the order of transactions and the transaction system too, and then we create a block. But if someone, for example, tries to create an invalid block, the rest of the network won't accept it, but remember it and then punish that peer. So in terms of cheating, you cheat before it ever gets into the blockchain, and we punish you before this ever had any real-world consequences, essentially.
I understand that. So you would punish the submitter. It's not a case that you would punish a bad validator.
So in this case, the validator would be, so a bad submitter would be a bad validator.
So submitter of the block.
Yes, because the submitter of a block is always a validator.
Yeah.
Yeah.
So you mentioned you want finality in a second.
Yeah.
So how does it cope with, say, if I'm pumping Bitcoin transactions to you, you put them on your blockchain, and then I have to do a reorg just because, and it's a genuine reorg, I'm not being malicious. You've got a whole load of final transactions. How do I say to you, hang on, all those transactions, they're different now?
Yeah,
do I
so
get punished for that?
so peg zones. Very interesting topic, and something we're currently actively exploring. For now, we're following the same model as so that we wait like 12 confirmations before we actually put it into the Tendermint chain. If there's so with Tendermint as well, you have out-of-band kind of governance system. So if there's an extraordinary event, for example, most of the blockchain gets attacked, the network gets DDoSed, or something like that happens, a major reorg happens on one of the peg zones, the validators can get together out of band and then reorganize the chain with more than 2/3 majority. Because, so that's essentially how, so these kind of edge cases are dealt with out of band, because otherwise you make this system insanely complicated. But yeah, active research as well, so this might change in the future, don't quote me on it.
You mentioned the inter-blockchain protocol. How does that compare to inter-ledger protocol?
I have not looked in depth into the inter-ledger protocol, so I can't answer that. I think that was a question about that.
Yeah, I'm glad you picked it first, but I'm kind of merging the last 2 points. So I've worked with Accenture on Hyperledger projects, and one of the more controversial issues on that was the ability to edit blockchain. But what safeguards or records or other things do you have in a Tendermint chain which signal to the third-party chain?
Could you speak up a little bit?
Sorry, what signal is there to third-party chains that are part of this consortium that out of band some other guys have got together to reorganize and reset a set of transactions?
All right. So that's about scaling the governance for now.
It's about relying parties understanding their understanding of the state of the world or their of economic value to third-party tokens as being changed under their feet according to the private development.
So the governance behind Tendermint and Cosmos Hub won't be private. So the validators will be distributed across the world, ideally on every continent, in as many countries as we can have, so in like 100 different countries ideally. And yeah, so this is a problem we will need to address. We're still actively working on the governance research and how to actually efficiently and fairly be able to update completely out of band when there's a massively bad event happening.
I thought we agreed not to talk about chameleon hashes.
Any other questions?
That was a life ago.
Is that the first law of blockchain?
Yeah.
Yes. You mentioned that you could use this technology to move coins from one blockchain to another. Is that using ILP, or can you compare and contrast to ILP?
I'm not fully aware of IOP, but I can explain to you how it essentially works.
Okay.
So here, since it's all these blockchains I mentioned are essentially proof of stake blockchains. So we can build very efficient light clients around them. So the Cosmos Hub is a light client to all the other blockchains. So we keep up with the validator set changes on all the other blockchains and the state changes. And at the same time, all the other blockchain, all the connected zones are light clients towards the Cosmos Hub. So when a zone wants to move, let's say one atom, or one base, let's call it one base from Basecoin, to the Cosmos Hub, it has an account on the Cosmos Hub that moves the money into, and this money only gets released when so it moves it to another zone, and then essentially everyone has an account on the Cosmos Hub.
So there's somebody sitting in the middle of all the blockchains, and they have accounts on each of them.
Yeah.
They receive money into one account and pay it out to another. So, okay, it's basically correspondent banking or...
Okay.
Sure. Okay.
Any more questions? Otherwise, I think we're good on time. Cool. Thank you very much, guys.